Okay, welcome to this screencast. Here we have example 3, obviously involving factoring. Also in this video we'll have example 4, also of a quadratic nature. Now, on the test we're not going to put factoring is involved in this question. We're going to put solve cotan x. Bear in mind it's multiplied by cos squared x equals to cotan x. How would you be able to observe that this is a problem where factoring is the appropriate mathematical strategy? You know, compared to those other examples that you've seen in the previous videos, isolate was the strategy. So this is actually taking you back through Algebra 1, Algebra 2, when factoring became something that was required of you. Well, you would have to notice that, well, first and foremost, there is a cotan x term on each of the sides of your equation. And then you would have to understand that bringing that so-called 2 cotan x, bringing it to the other side by subtracting 2 cotan x, puts you in a situation to perform factoring. Well, why do we have to do that? Well, the answer is because you can't isolate either of the functions here in terms of something known. Okay, so the isolate strategy worked well in those previous examples because we could isolate tan x or sin x in terms of values, right? Using inverse operations, divide, multiply, subtract, square root. That's not possible here, right? Because we have cotan x on both sides. We're never going to be able to isolate cotan x without also having cotan x on the other side. And then cos squared x, we could isolate that by dividing both sides maybe by cotan x is what some people think. But then cotan x disappears and we don't want that to happen. Okay, so what we do, we're stuck, I guess is the short version now with 2 minutes into our screencasting. How do you know you have to factor? You know, as we're in pre-calc now, we can look back at these strategies and understand when they're supposed to be used. In this equation, I see that I have the same trig function on both sides and another trig function involved as well. The most efficient strategy for solving this is to bring everybody to one side and set it equal to 0, and then you can common factor to leverage, remember, the zero product property. What does all that look like? It looks like what you see there, right? We bring everything over to one side, set it equal to 0. Remember that you've got multiplication between cotan x and cos squared x, and then cotan x acts as that common factor. X is not a factor here. Cotan x is a factor. Remember, cotan of our angle produces a value, and then cos squared x is also another different quantity. In my other term, I've got minus 2, which is obviously just the constant 2, times that cotan x again. So that entire cotan x acts as that common factor. It's like having the variable y written here times maybe w squared minus 2y. And we would know from Algebra 1 that you could pull the y out the front, so to speak, and then inside the parentheses is what I need to multiply to make the top. Okay, there's a review of factoring, but I think worthwhile. You know, in this case, we have a lot of excellent factorers in pre-calc, but when it comes to factoring with trig, it does add a new element of difficulty for your brain to process. And so there you go. That's your lesson on factoring. So now what's next? Well, just like you remembered from Algebra 1, Algebra 2, the zero product property states that if I have a product, and it's very useful because of this statement, if I have a product, something times something else, and the result needs to be 0, then it means that each of these elements in turn, I can find solutions out of there if I set those equal to 0. Okay, that's why you learned about factoring, and that's what we're going to use now. You're going to set up two equations. One's going to say cotan x equals 0. The other's going to say cos squared x minus 2 equals 0. And you should attempt to solve those two. I'll set that up, and then you can see what the solutions look like. On the left-hand branch, cotan x equals 0. That gets solved with pi over 2 plus pi n. Now you're saying, huh? I don't remember seeing 0 in my table of values of special trig angles. And you're right, it's not in there. The idea here is, guys, remember, if I have a 0 on one side, I'm thinking about quadrantal angles. And you have to remember the definitions and those positions around the unit circle and their ordered pairs to solve trig equations where quadrantals are going to be involved. How are you going to recognize that? Well, most often, if you have a 0, you're dealing with a quadrantal situation, okay? And you got to be a little bit careful, but a lot of times with the number 1, you're thinking about quadrantal. The exceptions with the number 1 are for tan and for cotan. Remember, because tan and cotan, when a 1 is our answer, so cotan theta equals 1, we'd be thinking about 45 degrees, right, or pi over 4. Okay, the definitions that you see here are things that you need to know. You already do know them, I should say. You need to remember the quadrantal situations. So back to the solution. I solved cotan x equals 0 is equal to pi over 2 because the cotan ratio is x coordinate over y coordinate, and pi over 2 is the first instance when I get to a scenario where I've got 0 for x over some value, right? So we've got 0. It's not incorrect to be thinking 3 pi over 2, and if indeed you put 3 pi over 2 plus pi n, that's not incorrect, okay? But we only need to put, and usually the case is we go to the first angle as we rotate around counterclockwise, and we just write that one, okay? The second set of solutions would come out of what you see there, cos squared x equals 2. If you want to solve that equation, you need to take the square root of both sides, and as you may or may not be aware, square root 2 is approximately equal to 1.1415. All right, now, what is that? Well, that's a number that's too big to be on the unit circle, so actually that doesn't yield any more solutions because that's outside of the range of cosine, right? The idea here, cosine of an angle, that can never produce a value greater than 1 or less than -1. So we can't solve that equation for any values. I just do need to tidy up one thing here that I've thought of with my root 2. That's 4, 1. Sorry about that. 4. Back to what we were talking about. When it comes to solving these trig equations, we do also need to remember the knowledge that we got in the first semester about the range of these trig functions. Cosine in this case, and sine in other cases, their ranges are between -1 and 1. So if you ever come across an equation like this, where I would be asked to find an angle, with or without a calculator, it's not possible to find a solution to this part of the equation. And so our final answer is, for this equation, x equals pi over 2 plus pi n.